Okay, so I'll just write this down and let me know if you have anything that you would like to know. So the contents for week 1 are the following, right? So the professor discusses some history of deep learning and how the whole thing started. So that's very important from a general point of view of understanding where we are in the deep learning landscape. But apart from that, from the exam or concepts point of view, it's not that important. So the actual lectures, they start from what we call the Macaulay-Pitts neuron, right? So this is the first artificial neuron. So there are two kinds of artificial neurons that are discussed. So there are two kinds. One is MP neuron. It's a very simple neuron. The other one is perceptron. Okay, so there are some similarities, some differences between the two artificial neurons. Next week we discuss sigmoid neurons, but we haven't gone there. So rest of week 1 is about discussing what perceptrons are capable. So we have a discussion surrounding what is called linearly separable data sets. Okay, so errors and error surfaces. So what are the errors that a perceptron can make, and how does the error surface look like, and how do we learn the weights of a perceptron? So that is what is it called? Perceptron. The perceptron. I'm sorry, spelling is kind of tricky. Learning algorithm. That's what it's called, right? So this is, yeah. So perceptron learning algorithm, proof of convergence. So the idea is this algorithm actually converges. So proof of convergence is discussed. So this is what is there in week 1. All right. So these are the topics in week 1. You must be familiar with all these things. Graded assignment is not very hard. So I hope you would have taken a look at the graded assignment. There are some 6-7 questions. I don't know exact number. So you should be able to do it if you have watched the lectures. However, if there are any questions in any of these topics, you can ask. Yeah, go on. You don't even need to raise your hand. No one is talking. So you can go ahead and ask.
Sir, one question from the practice assignment. There is number of Boolean function. It is given 0, comma 1 to the power n. If n is 1, then what is the number of Boolean function? That part is, I'm not understanding that what exactly.
Yeah. We'll discuss that. So something like this you can ask, right? So I'm ready to discuss that. So let me first take a screenshot of that question so that we can discuss it here.
Yes,
Okay,
sir. The question say, and what will be answer if n is 0, 1, 2, 3? How to approach that,
correct.
sir?
Yeah. So that is, we can discuss that. So this is the question. Okay, let me zoom it. This question, right?
Yes, sir. Right, sir.
Yeah. So what is this question asking? We know that a Boolean, the question reads, we know that a Boolean function maps 0, 1 cross product, right? So what does this 0, 1 power n mean? So 0, 1 power 2 is nothing but 0, 1 cross product 0, 1, right? That's what it means. So you pick something from here, you pick something from here. Basically, the set of all tuples of size 2. So 0, 0, 0, 1, 1, 0, 1, 1. That is what 0 power n, 0 power 0, 1, 2 means. Now 0, 1, we are asked 0, 1, 1, right? So to the power 1 is nothing but the set 0, 1. So nothing fancy here. It's just the set 0, 1. Now the question is how many, first of all, let's look at the number of, we'll ask the question, how many Boolean functions are there from 0, 1 to 0, 1, right? So this is a one step before we go to linearly separable Boolean functions. So how many functions are there from 0, 1 to 0, 1? Boolean functions. Does anyone know the answer?
Sir, 0, 1 to 0, 1, if it is input, then there could be one
It will be
function which is
4.
taking one input and outputting two, and there could be function that is taking two input and output. So something like that. I
Right,
am
but
thinking.
yeah, it is actually 4, right? As Vivek pointed out. So Vivek, it's good to meet you again.
Yes, sir.
Yeah. So we met, I think, 2 years, 3 years back.
2 years back. Yes, sir.
Yeah. So anyway, yeah. So see, this is, what is this actually? This is, let me add a table. Delete one column. So this is x. This is f of x, right? So now one function is if x is 0, f of x is also 0, and if x is 1, f of x is 1, right? So this is, for example, right, this is one function that we can come up with. Now there are, of course, you could change this. This is some other function. If you end up changing this, this is some other function. So the input doesn't change. The input meaning the input column remains the same, but I have how many choices here? 2 choices, right? So I can choose 1 or 0 here. So every choice will give me a different function. So therefore, there are 2 into 2, 4 choices. Okay. Therefore, 4 functions are possible. Correct? Is this clear? So there are four possible functions from 0, 1 to 0, 1. So we can kind of represent them as following. So 0, 1, 0, 1 is one function. So what you are doing is input, first coordinate is input, second coordinate is output. So other one is 0, maybe I will be a little more systematic. So input output is 0, 0, 0, 1, 0. This is one function. What is the next? Can you complete this table for me? What could be the other function? So first coordinate is input, second coordinate is output.
1, 1, 1.
Sir, always output.
Yeah, always output is 1. That is
0,
one
1 and
possibility.
Yes.
What are the other things?
Always output 0.
That I have given here, 0, 0.
One time for 0 output 0, for 1, and other is reverse.
Yeah. Okay, so these are the 4 possible. What is missing? 0, 0, 0, 1, 1, 1. Sorry. What is missing? 0. So the proper way of writing it so that we don't get confused is 0, 0, 0, 1, 1, 0, 1, 1, right? This is typically how binary is written. So these are the 4 possible functions. Is that correct? Where I represented it as, so representing them as, how am I representing it? Input, comma, output. So there are 4 possible Boolean functions from 0, 1 to 0, 1. Now the question is, how many of them are linearly separable? Okay, linear separability, what does that mean? What do we mean when we say that a function is linearly separable?
We could have if it is a graph, then vertical line can divide that.
The data points should be divided by a linear boundary.
Yeah, both of you are correct. What you are mentioning is correct. So if you have, we have actually, this is kind of easier to understand when you have multiple variables. So if you have, say, x1 comma x2, right? Here f is a function of 2 variables. Now a linear function would be if there are 2 features, right? If there are 2 features, x1 and x2, a linear function will be of the form w1 x1 plus w2 x2. Is that correct?
Yes.
Or will there be something else also?
Bias.
Yeah, plus a bias term, right? So this will be a linear function. This is how it will look like. Now, this will be a line in the plane, right? So this we'll come back to that. So this is a linear function in two variables. Now, if you have just one variable, okay, you have just what do you have? You just have x with you. Okay, this is, remember, this is of the form x comma f of x, right? That's what we have given here. So you have x here, and therefore the linear function. Can you tell me what the linear function will be? Similar to this, what form will it take here if there is only one feature?
Simply x1.
Do we need x1, or you just have one feature, right? So what is a linear function of a single feature?
Wx plus b.
Yeah,
W1
wx plus b, right? That is all. Just have weight into feature plus b. So if there are multiple features, you have weight 1 into feature 1 plus weight 2 into feature 2, right? So if you have only one feature, you just have weight into that feature plus bias. Okay, now the question is, yeah, so this is a linear function. Now we come to, so let me remove this. So a linear function looks like this. Okay, so what we are asked is, which of these functions, what is the question again? How many of these are linearly separable? So what does that mean? Okay, actually function cannot be linearly separable. It's better to talk about the data. So, but anyway, what do we mean when we say some of these are linearly separable?
A linear boundary should
Correct,
correctly
right? A
separate.
boundary. So easier way is to draw this. Okay, there is only the x-axis. If you think about it, we don't have a plane. There's a single feature, and this is the x-axis. Okay, maybe we can add direction in both the cases. So okay, so let's try to understand one of these functions. Let's say 0 0 0 0 0 0 1 0. So let's try to understand the function where input is 0, output is 0, and maybe input is 1, output is 1, let's say. Okay. Yeah, so how will this function look like? Let me say that this is let me call this green. Green means label 1 or function's value is 1. Okay, and red means function's value is 0. Okay, this is the function's value. Now, is the ordering correct? So I have x equal to 0 and I have x equal to 1. So is this representation of my function correct?
Yes, sir.
Okay, so this is the function, right? So x equal to 1, it is positive, meaning 1. X equal to 0, the label is 0. So this is, yeah. Okay, now think about linear separability. What does it mean? In 2-dimension, it is drawing a plane, it's drawing a line and making sure that all points of the same color lie on the same side of the plane. So what do I mean by that? Let me draw that also. So you have an axis. This is 2-dimensional case. We have done that. So that is kind of easy to understand because we have seen that in the lectures. So this part we have not really, even though this is only one feature, it may be slightly non-trivial, okay, because we have not seen it. So let me add few data points. This is okay. So it's not really a Boolean function, but it's fine. What we want to understand is linear separability. So let me add few points here. Okay. Sorry. Yeah, let it be like that. Okay. So what we are trying to do here is, this is your line which is separating the point. So we say that the data set is linearly separable, or whatever function is there behind this data set. So you can think of that function as, so do you all agree that this is also a Boolean function, what I have drawn here? So this is f of x1 comma x2. So if I call this x1 comma x2, okay, so what is f of x1 comma x2 for this red point? Red means 0, green means 1. So f of x1 x2 is, for this red point, it will be 0, right? Do you get that?
0.
Okay, so this is what I want you to understand is this, what you see here is actually a Boolean function. So there will be some value of x. So there will be, say x1 could be 1, x2 could be 1, and this point might be x1 equal to 1, x2 equal to 2, things like that, right? So I hope you understand what this is, right? So this is x1 axis, and this is x2 axis. Okay, if that was not clear. Okay, this is a Boolean function of two variables, two inputs, one output. Output is always Boolean. So this will be 1. All the green points, the f of x comma y or x1 and x2 will be 1. Okay, this is an example of a, we annotate this. So this is an example of a linearly separable Boolean function of two variables. Okay, so that's what this is. Now, what we are trying to understand is, how does a linearly separable function in one variable look like? So how will it, so is this, can you tell me if this is linearly separable or not? What you see here? Yes, no, thumbs up for yes.
Since it is in 1D, so I'm not getting about how we can talk about separability.
Yeah, so what will you do? So here, what do you do? So wx, so geometrically you see it's linearly separable. Algebra wise, what will you do? You'll ask the question, is w1 x1 plus w2 x2 plus b this quantity, right? So there are two cases. This quantity, if it is greater than or equal to 0, then we'll call it 1, right? And if this quantity is less than 0, we'll call it 0, right? This should be possible for all the points, right? For all green points. So what are we saying? We are saying that if it is a green point, then this condition should be satisfied. If it is a red point, this condition should be satisfied. Okay, that's what linear separability means, right? W transpose x plus b greater than 0 for positive, W transpose x plus b less than 0 for negative or class 0. Algebra, that is how the geometry and algebra are connected. Okay, it will happen for this line, right? Whatever line this is, for all these points, wx plus b will evaluate to positive, and these points it will evaluate to negative. So coming back to this, what do we have? We have a, can you find a w and b such that wx plus b is greater than or equal to 0 for the green point? There's thankfully only one green point and one red point. Can you come up with w and b so that this happens for this situation?
So instead of line, will we have another point, something
Exactly. Yeah. So
beyond
we actually won't have any line, but you can sort of visualize this as another point, as you said. So this point I can move here and there. Okay. So if I move this point here, so one way, right? One possibility is set w to be 0. So I don't know, not w to be 0. So can someone tell me what will ensure? In fact, yeah, I want you to tell me what will ensure that w into 1 plus b is positive and w into 0 plus b is negative, right? So I'll write down the equation. Tell me if you agree this is what we are looking for this situation. w into 1 plus b, right? Wx plus b, that is for the green point, that's labeled 1, right? So it should be positive. This is
We
less
can
than
set
0. We
bias
all agree
to
that this... Sorry, yeah, we can set
bias to -1.
we can set bias to... Okay, what about w?
Greater than, so B
W
could
could be 1.
Okay, you're
Just
telling
1.
me w could be
it
1,
should
okay.
be greater than
And B is
uh,
-1.
minus B, greater than minus B. It should be.
Okay, so okay, yeah. Oh, so someone is... sorry, I didn't see who it was, but someone is suggesting that we actually simplify this as w greater than or equal to minus b and b less than
0.
0. Okay, so from this, can you tell me some suitable w and b?
We could take any random B, so -1, -2 first, and then we can substitute in above equation to get W.
Okay, then yeah, but any one value, right? So
One.
just tell me some
-1.
value w equal to minus 1.
B.
Equal to 0.
No, B is equal to -1.
Okay, b equal to minus 1 and
W is greater than -1, so it could be 0, 1, 2, anything. 1.
w is greater than or equal to minus b, right? So w can be 1, right?
Yes, sir.
Does this work, everyone?
So mathematically we are getting B, but like in the diagram, like where we will have the intercept or something.
Yeah, interpretation. Yeah, so I probably confused or complicated it a bit. So let me just add it this way. So what are we looking at is, what is wx plus b greater than or equal to 0? Wx plus b greater than or equal to 0, okay, is what we want, right? This is the same as saying x greater than or equal to minus b by w, right? So what is x greater than or equal to minus b by w? Mathematically, it is just the interval, right? It's an interval starting from minus b to w, going all the way till infinity, right? So what is an interval? This is exactly an interval. So I have probably, I can, so there's no other, so an interval has a start point, that is this point, this line that you... It's not a line really, it's a point, as you said. So it starts there, goes all the way to infinity. So all that you need to do is find out minus b by w so that it is somewhere between these two. In fact, any minus b by w will work as long as it is there in this range, right? Because starting from here, as long as x is greater than or equal to this point minus b by w, I am going to classify this as 1. Anything less than that, I am going to classify this as minus 1. Okay. Is this part clear to everyone for this one function? Yeah, recording will update. But yeah, is this for this function 0, 0, 1, 0, is it clear? Okay. So what? Now it should be clear. Let's go back to the question.
Sorry.
Yeah.
Can you just repeat the last line? The range you said.
Yeah. So see what is the predicted label, right? So what we need to understand is, what is the function really trying to do? The function is trying to do the following. So f of x equal to y hat, right? So this is we call this y hat, right? So y hat, that is the predicted label. It is either 1 or 0, and that depends on the sign of wx plus b. So if wx plus b, it is 1. If wx plus b is greater than or equal to 0, if not, I am going to predict the data point as 0. Okay. Now, this is the same as saying that y hat is nothing but 1 if x is greater than or equal to minus b by w, and it is 0 if x is less than minus b over w, which is the same as saying that any point that lies in this interval minus b to w comma infinity I'm going to classify as positive. Any point that is in the other interval, I'm going to classify it as negative.
Okay, yeah, understood.
Okay, now, so in the two-dimensional case, you had to find a line. In the single-dimensional case, for linear separability, you just have to find a single point. And that point is minus b over w. Okay, now the question, going back to the question, how many linearly separable functions are there? We know that there are 4 Boolean functions, namely these 4. We have shown that one of them is linearly separable. How many are the other 3 linearly separable or not?
We have to check, like, draw the boundary and
Okay, do we need to check, or
Well,
is it
there are 2
kind of
points, so there is always a boundary.
I
So
think
whatever the color is, we could always have a boundary, sir.
exactly right? So what is the, that means all functions are linearly separable, right? So that's why the answer is 4. So if you think about it, this part is clear to you, right? So I'll just change the label. Instead of calling this, let's take another function. All that I need to do is I don't change the input. I only change the label. So let's make this also 1. So this function is 1, 1. So where should I move the point minus b by w? I can move it here. I can move it
Left.
here,
Left.
since
to the left of x equal to 0, right? Anywhere. So I can move this
left.
anywhere. So everything to the right of this will be positive. Now, second function is done. If you now change this to red, let's say, that's the third function. Okay, so where should I move this line now? This point rather.
Somewhere in the between.
This is interesting. In fact, so
We need to revert it.
we need to reverse it, right? So how do we reverse it?
I think the answer that was the previous, just we need to change the sign of B and W by multiplying with minus.
Okay, so let's see. What we need here is, sorry, this part alone I want to change, right? So this is what we need is wx plus b. See, I want the rule to be still this. Correct? But with this, can I achieve? I'm a bit confused here. So, any help? How do we do it here?
Karthik sir, if you go back to the problem on the
Hmm.
top, see, the problem is which one? Sorry, the exact
How many
one
are
is
linearly separable?
in this one, right? See, n is equal to 1 implies what? N is equal to 1 implies there is only one data point, correct?
There are 2 data points.
No, 0, 1, I think are the values that data point can take.
Correct? So there will be like 0 is one data point, 1 will be other data point, right?
I'm wondering if we have got that, if we have understood that incorrectly, because from what I understand, 0, 1 are the values a data point can take, and n implies the number of data points. So if we said 0, 1 power 2, that means that there are 2 data points, and each data point can take 2 values, and the number of Boolean functions will be 2 power n, which will be 8.
No, there are only 4 Boolean functions here, right? So see, this is the cross product, right, between 0, 1 and 0, 1. So 0, 1 cross 0, 1 cross 0, 1 n times. So there are only 4 functions in total, right, here. 0, 1 power 1 is just the set containing 0 and 1, right? So there are actually only 4 functions, and the claim is all 4 are linearly separable. Is that correct?
Yes, sir. I figure out it is 1 and -2 and 1, W and B. Solving the
you're saying
inequality that you made.
Mm.
okay.
-2
So
and
yeah,
1.
good. So the point where we missed was here. So Wx plus. So where are we? We are in the situation where, see, this is still the same. So what mistake did I make here? So can someone tell me there is a small mistake I made here while dividing by W?
It could be 0 also.
What happens if, so is
And
this
it could be a
equation
negative value also.
exactly? Yeah. So if
Negative.
W is negative, this is wrong. Okay. So that's what has happened. Now, in fact, you can actually fix a negative W, and that will. Okay, so that will change the. Let me know if this is clear. This is the mistake I made there. So that was for a positive W. Now, if I choose my W to be negative, okay, I can still, left hand side is correct. Left hand side is still y hat is 1, 0, Wx plus b greater than or equal to 0. But if I explicitly choose W to be negative, let's say, right? So I'm choosing a negative W, I'm calling it minus W. So what will happen to my equation in this case?
Reverse.
Yeah, so x is greater than x is less than or equal to.
No, it will be less than only, no, sir. Not equal.
No, I'm choosing, see, W is still positive, but I'm calling it minus W for convenience.
Okay, okay.
Right? So W is still positive. So my interval will change. Is this clear to everyone? So the interval is now from minus infinity to 0. So anything in minus infinity to 0 is positive, and anything from that to infinity is negative.
That minus will also come, no? Or no, okay. W is minus. Okay, get it, sir.
Yeah, yeah. So here we assume that W is greater than 0. Okay. And here also W is greater than 0. That's what allowed us to divide. So this is the other case. Now the final situation would be where both are negative, meaning both are red. In that case, I can shift my interval to
Right.
one. This is
For
this
negative
is
one left. Yes.
left, right?
Hmm.
Okay, so these are the 4 cases. The other case, of course, I haven't explicitly mentioned, but let me add it for the sake of completeness. The 4th situation would be like this. So that would be like this. So these are the 4 linearly, there are only 4 Boolean functions. All 4 are linearly separable. In one case, you move the point to the left, all the way to the left. In the second case, you move it in the middle. The other 2 situations happen for the case where other interval is positive. Okay, so what is the point of this? I'm genuinely asking because you are 100% sure you have missed something because of which it feels like.
Actually, this is a very confusing problem. I did the same thing in the last term. Actually, it starts making sense when you take n is equal to 2. And there's a confusion also how that binary strings are represented. I would suggest we revisit this later and focus on the rest. This is very confusing, unnecessarily confusing.
Well, I kind of differ. So it's actually a very interesting question. It's just that we are so used to thinking of R2, right? So we are so used to thinking of R2 that the question is just asking you to do something which is simpler. Think in R1.
No, actually, I'm saying so actually it's a, if you go to that 0, 1, my understanding power n, right? So this is actually, it's a trivial problem in a way, because 0, 1 power n means n is equal to 1 means there is one data point which can take either 0, 1.
No,
or
there's
0.
no data point, right? It's a function. See, we are talking about the class of functions.
By data point, I mean the input it takes.
Correct.
It's
Input
one.
can be two, 0 or 1, right?
Yeah. So it's saying that when I take 0, I can have two outcomes, either 0 or 1. When I
Correct.
have 1, I can two outcomes, right?
Yeah, therefore there
So
are 4
with
possible
0,
functions.
4 possible mappings, right?
Exactly, yeah.
Now for 0 to 0, 0 to 1, they're all trivially separate, but they're all independent. They're trivial. You can always separate them.
Correct, yeah. That's the whole point, right? That's what we just proved. So we proved that all 4 are separable.
Okay.
Sir,
Okay.
what
Okay.
will happen
I think
Sorry?
if n is 0, sir? How to find the output?
There is no function, right? If n is 0, there is domain is empty. So that's like the null set. And that's very trivial, right? That is really trivial. So, but if n is 1, also it's trivial. I understand it's probably meaningless from a deep learning perspective. It's meaningless, but then, yeah, okay, yeah. So I agree that we have spent a lot of time, but I hope people understood somewhat at least what's happening here.
Yes, sir. So one last thing to confirm just about the interpretability of the term D bias in the simplest form 1D. So is it the factor which is controlling that? Suppose in this example we have the green one and the red one, and we have the line in the middle somewhere. So is it the B which is the factor that will control that just after what value of after the green part, like we are separating those data points. So like in
What does
2D,
B?
sir, in 2D, like the interpretation of B is that we have that intercept in the XY axis, that intercept here in the 2D.
Yeah, good point. So B controls the parallel movement of the line, correct?
Okay.
What does in that case in 2D, that's what it controls.
Hmm.
What does it do here?
Is it setting that minimum range, like just after the green we have the area for the red one? So what just after would be? Is that the factor that would be controlled by B?
A good point. I am also not very sure. So what happens when x is 0? So the sign of B controls what it is. So this is, I'm not very sure, boss. I'll have to get back to you. In 2D, it is very clear what B controls. It controls
That parallel
where,
movement.
exactly, right? So where this
Yes,
moves.
this one.
But what does it, is there, what is the role of B in 1D? Yeah, it's not entirely sure.
Okay.
Okay. So yeah, we'll move on to some other questions. So
So
you have,
if
yeah.
you could just go up here, yeah. See, I think what Vasu was trying to explain, that you have 0, 1 to the power of n, right? So this 0 and 1, you can assign values to it in 2 to the power of n ways,
Yes, correct.
right? So you'll have the truth tables basically.
Hmm.
Now, each of these truth tables, if it has an output which is binary,
Right.
0 or 1, then you will have 2 to the power of 2 to the power of n possible
functions,
outputs, yeah, functions or bio, right?
mappings, or whatever.
See, I am kind of, this question, I won't interpret it that way because, see, what is this? So a function has two things, right? The domain.
I think counting number of function. That
Exactly,
but
yeah.
here it is saying linear separable.
Correct, yeah, which is the same. So, okay, so see, let me change this to the following, right? So let's ask the question of n equal to 2, right? Possibly n equal to 1 is what is causing the confusion. So let's start with how many, let's first discuss this. How many Boolean functions are there from 0, 1, 2 to
Right.
0, 1, right? Let's discuss this. So let's start from this.
16.
So what do you think is the answer?
So
16.
16.
No, yeah, here that's correct. There are 16 functions. I also agree, right? So how many are there from 0, 1, 1 to 0, 1?
So sir, what's the question? How many?
How many are there? So there are two questions, right? So you said the answer is 16, which I agree. Which, how does that come? There are two inputs. Okay,
Correct.
that's the domain, right? The domain is 4.
Correct.
And therefore, for each input, there are 2 power.
Two possible.
Right? So there are 16 functions possible.
Yeah.
16 functions are possible, right? So you ask the same question now for 0, 1. Power 1 is nothing but 0, 1 itself. Okay, how many inputs are there? There are 2 inputs, right? So I'll just erase this. So there are 2 inputs. Each input can take 2 values. So there are
4.
2 square values. So there are 4 functions, right? So there are 4 functions. That's what we were.
Correct.
Right. So each input is a data point. You can look at it that way. So for example, here there are 2 data points, and the color is what gives us different functions. Are these functions linearly separable? So the linear separability, now we can think of where do you place this point so that everything to the right of it is green, everything to the left of it is red.
Yeah. Now I get it the way you were explaining, right?
Yeah, maybe the feeling is probably a bit.
No, it's perfect.
But
you are just explaining it from the input side.
Sure.
Yeah.
Sir,
Yes.
but we need to make sure that all are linearly separable. Out of this 16, there will be some function which are not linearly separable, right, sir?
Correct. Yeah. For the two variable case, there are the XOR is one example, but it turns out that for the one variable case, none of them are. So all of them are separable.
Sir, how will be the input output means number of function if n is 0?
See, if n is 0, the domain is empty, right? So that's no longer a function. So,
sir, but it is a question in graded assignment.
oh my God. Okay.
N is 0.
Okay, that should probably be removed. So we will not do machine learning without having input. So we should probably remove the question.
That was very funny.
Yeah, I understand that these 2 questions are kind of probably unnecessarily there, right? As I don't know who someone pointed out in chat also. These are okay. Anyway, so we'll kind of get back to this. Any other questions from this week that we have to discuss regarding the MP neuron or perceptron, linearly separable data sets, error surfaces, learning algorithm, proof of convergence?
Sir, can we have a proof of convergence in tuition?
Okay, I think the prof himself gave it. Maybe I'll just repeat. I'll just repeat that, at least the way I understand it. So, see, you have a vector. Okay, so you have a vector. Let's say x is x, and okay, what is this? Actually, one of the data points. So let's say this is the positive data point. So the positive data point is represented by the vector x. This come to the front. Okay, so x is the data point. Now, let me draw one dotted line, which is like perpendicular to x. Okay, some dotted line. Okay, this is 90 degrees. Now we have w. Okay, at some point in the perceptron learning algorithm, let's say w looks like this. This is w. Okay, so if w is like this, and green means always positive, right? Whenever I do the session, green will mean positive, or y equal to 1. So this is y equal to 1. Okay, now if w is this and x is this, as you see here, do I need to update my weight vector?
No, sir, it is already in positive.
Correct, right? So it's already W transpose X is already positive because this angle is acute, so I don't need to worry about it. Okay, so the real situation where I need to probably think about updating X is when W is like this, the angle is obtuse and X is something like this, right? So this is when I would want to update. And as you know, what is W new?
W plus X.
Yeah, W plus X, because X in this case happens to be a
It will be
positive
in
data point.
between.
Correct. So what will happen? So geometrically, what's going to happen is this is the parallelogram law of addition, right? So the W plus X will give you W plus X. So this is W. I have drawn X there. I have translated X there. And the outcome is W plus X. So W plus X will be, or W new will be this vector. Okay, this is W. This is W new. Of course, I can complete the parallelogram so that it's clearer what's happening. So we can complete this whole parallelogram. You can change this to a dotted line so that it's not confusing. So this is W new. So this is W new. This is W. So the idea is once you change W, once you make the update, the angle between W new and X decreases. Okay, so it need not always be acute. For example, the situation need not always happen. What could happen is it may still classify it incorrectly. For that, what you have to do is you have to visualize what would happen if X is very small. Okay, so if X is very small, what will end up happening is your
It will
angle
be
between, it will still be less, but then it will be smaller.
What
Okay, so what will
W?
happen is, yeah, it will look something like this, and the W new will be like this. Sorry, I'll just make this properly aligned. Now notice that the point is still being misclassified, but the misclassification is not as bad as it was before. Okay, because the angle between them has decreased. So that's the main intuition. When you do an update and get a new W, the angle between X and W decreases. It increases if X is negative or labeled 0. Okay. Any questions? Does anyone have any questions regarding this?
So this intuition is okay, but why it will converge? Means we are adding only X, no? We are not changing the weight of X. So maybe we are one way changing, adding the same X and subtracting the same X. That could be a problem.
No, we won't subtract the same X, right? So see, whether you add or subtract depends on the label of X, correct?
Yes, sir. Yes,
Do you
sir.
agree?
I'm
So
getting the intuition why W is leaning, but will it converge? That is
yeah,
I
so
was
see,
asking.
there you have to, I agree. So there you have to kind of see, the intuition cannot take you all the way till convergence, right? So this intuition is for, see, what does this intuition tell you? Locally, it gives you justification for a greedy update, right? So what you're doing is kind of a greedy update, meaning this intuition. So for that data point, something good happens. Okay, earlier it was so bad that it was being misclassified terribly. Now, perhaps it is still being misclassified with W new, but it's not as bad as it was before. So you are doing a local update. So that's, intuition can only give you a justification for why it is better for this data point. Globally, why is it better? I don't have an intuition. I just know the proof of convergence, right? So mathematically, that should convince you. But if you want to, somehow they all come together and align, the stars align perfectly. So I don't know if that's convincing, but yeah, I at this stage I don't have an intuition for how all these updates somehow orchestrate so nicely, and yeah, that part I don't know. Okay, anyone else? Any other questions?
No, if you just extend this intuition till the time,
Yeah.
see, it will again correct for it. It will keep correcting till the time it's aligned in a way such that you get a positive result for W transpose X, right?
Right.
Now, the same thing happens with the other points. Let's say it was negative, then it would move in the opposite direction. And it
Correct,
does
yeah.
that. Yeah. So eventually, Prashna, what is the point? What? Okay, I'm just extending that in theory in my mind that, hey, this will keep correcting till the time it's aligned.
Agreed, yeah. So I agree. Only thing is, I'm not able to see. So it's locally, it's correcting, right? So at every point, it's correcting itself. To me, it seems I'm not able to extend that to see how.
It will happen globally.
Yeah.
Like the
Mathematically, I am convinced.
since it is correcting and if it like in this situation it has corrected, not correctly classified, but the angle will definitely reduce. So in a sense, the cos of that angle, in a large number of iteration, we will reach the limit where the cos will be increasing and cos has a boundary.
Correct, yeah. So that what you're saying is the proof. The proof says that, right? So cos alpha, cos beta is bounded above by 1, therefore k cannot go beyond. Yeah. So yeah, I also get that part, but does it qualify as a geometric argument? I'm not sure. I think that's what Hrithik is asking when he says.
Mhm.
Yeah. So any other questions? So if you have any questions, please. Others. Okay, if you don't have any questions, I will ask one question, and you can answer. Okay, so this is something I observed. Now, let me open the slides.
Sir, just a second. Someone else asked, pointing out a question from graded assignment where n is equal to 0, the domain is 0 for that Boolean function. In that question, it is explicitly mentioned that the function allows empty element as an input.
Is it 1 second? Which is that question? Yeah, this is. I remember getting stuck on that as well. So
yeah, it is question 4 from GA1.
Okay, empty. Okay, so let's revisit. So this point I remember searching. So let's. Okay, I won't discuss the actual question. I'm not allowed to, but we can discuss when a function. What is the definition of a function? So, what is a function? If a function, so there are for every x in the domain,
There's a unique Y.
there is a unique
Y in the codomain.
Okay, unique Y in codomain. Okay, this is one. Now this is, even if the domain is empty, this is vacuously true. Okay, this is vacuously true in the sense, even if the domain is empty, this is true, because there are. I mean, this is like a very confusing thing in math, but yeah. What is the other condition? Is this the only condition for a function, for something to be called a function?
Our domain needs to be fully used, and codomain can be not fully used. And
That's basically, Karthik, that's subsumed in this. Basically, this is the definition.
This is the one, right?
This is the only one. This is the basic thing, that
Yeah.
it has to be mapping to a unique element in Y.
Right. So, see, I read in this, I actually looked up Wikipedia and they said that, I remember reading that the codomain cannot be empty. So, wait.
No. So the
I am
domain,
reading that. The codomain cannot be empty. Range can be empty. That's what someone said. No outputs are actually produced, if that is the case.
Right. Yeah. So, see, I'm kind of not sure. So, the formal definition probably goes via relations. Okay, so let me pick that up. I'm sorry, this question should have been scrapped. Should not have had this question because it's not really fitting into the deep learning frameworks that we are studying. So see, this is the definition that I looked up. Now, let me copy it verbatim. Anyway, meanwhile, if anyone has a deep learning doubt, please keep that in mind. We can discuss that. Okay, so this is the formal definition as per Wikipedia. What does it say? A function with domain X and codomain Y is a binary relation between X and Y that satisfies two conditions. For every X in X, there exists Y such that X, Y in R. This is vacuously true. Even if X is empty, it's not a problem.
Second one is just to ensure a one-to-one mapping.
Right. Yeah. You
No,
don't
and
have.
the inverse exists, kind of.
There was something in Wikipedia itself that says that
Okay, even if we set this apart, the conditions, we can still vaguely say that the domain is an empty element or an empty tuple, say, and
correct.
the range is 0 and 1, a set of two values.
Yeah, but this is sure. Yeah. Okay. So can you? What I will do is I will. This is actually a bit tricky. This is more a math. This is like heavy math question rather than.
Actually, that thing of empty set and all, because it's actually a mapping of from set to set, and it depends on how you define the set.
Correct. Yeah. So
And
what we
that
will do is
comes in category theory and all that, very advanced, like very advanced concept as to why empty sets are acceptable and things like that.
correct. Yeah. So this is what I will do is I will clarify this on discourse. I hope you're all on discourse. This is kind of yeah, it's not really a good question to ask in a deep learning course. Okay, so just hold on. I'll maybe by Monday I'll clarify. Next Sunday is the deadline, right? Not this Sunday, I believe. So I'll clarify this. This is a bit tricky. Okay, so any questions? If not, I will ask some question.
Sir, small thing, small request. If you could throw some light that in the Macaulay pit, we don't had weights, but
We don't have.
we don't had the concept of weights there. We had a particular threshold, and we were giving the output based
Right.
on that. But like someone, how could have thought of that we should some, of course, mathematically there also we had some equations and we were solving the things like what should be the output. In the neurons also we have this, but addition of weight made some variables free, like earlier in the Macaulay where we had two contradictions between variables, but adding the weight made them free, and we were able to classify more points that were not possible in that.
Okay.
So I was not getting the intuition that like how mathematically someone could have thought of that, like just adding the weight would help us in solving the equation that were not earlier possible. Like we were having two contradictory equations where one like a is greater than b and at the same time a is less than b. That kind of contradictory statements we had when we had metallic weights, but adding the weight made them in two different equations, like a will be greater than something, b will be greater than something, and we can solve them separately.
Okay. So see, I don't know if I understood it correctly. So the MP neuron, they probably came up with that model inspired by what was happening in biology. That's what SAR says, right? So there's no question of. See, they only tried to model a stimulus response pattern, right? So there is a stimulus, meaning there are inputs, and then based on those inputs, if the inputs are beyond a certain threshold, something happens, which we call fire. Okay, so the neuron fires if stimulus is significant to cross a threshold, right? So there's no question of, I don't think they were trying to model an artificial neuron from the machine learning perspective, right? I may be wrong, but the MP neuron doesn't seem to be it's probably a bridge between, it's some model of a biological neuron, but it's an artificial neuron, right? It's an artificial neuron which tries to model how biological neurons behave, probably, right? In extreme oversimplification. So does it have anything concrete or tangible to do with machine learning? I don't think so. That probably started with Frank Rosenblatt's perceptron, right? So that there the idea was to learn from data, right? And therefore weights commit. So the moment you want to learn from data, you need to have some tunable parameters which can
Yes.
capture the essence of the data in some manner, right? So I don't know if MP neurons were built for data science / machine learning, right? So I don't think they were built for that reason. At least that's my understanding.
Okay. So the takeaway is that like to have the understanding or to grasp more complexity, we should have that parameter thing so that we can tune up with the data.
I
Right. If
think
you want to, yeah.
perceptron makes sense with the technology only. So before 1950 or 1970, there is no computer. So why someone will think to make a machine learning model that could learn if there is no learnable thing?
Yeah, but see, you must also remember that statistical learning was there before also. For example, linear regression, right? So they didn't call it machine learning, but regression has been there since the time of Gauss. So it started with astronomy and trying to predict the orbit of stars. So regression is like older than everything, right? So the idea of approximating something using a function having parameters is probably older than computers, right? So that's why if you look at some textbooks, they are in fact called statistical learning theory. So that the machine learning has its origins in statistics, right? That's why we do regression, logistic regression, all these things have statistical origins and they predate all the computers and all these things. Yeah, but I agree. My understanding is that they probably came from uh, biology, right? So these are two different things. Okay, so this is my question. This is the question that I want to ask. So I'll have to mute for some time now. This is the proof, right? So this is the last step in the proof. So does anyone find anything odd in this proof? So do you find any gaps? Okay, so there is this line, right, which says cos beta grows proportional to root k. Now, when is that likely to fail?
Sir,
Zero.
I think
When k is
cos
0,
beta grow when it is pi by 4 to pi by 2. Sorry, pi 0 to pi by 4.
Okay.
Sorry, I forgot the domain range.
See, as k grows, says that it is proportional to root k because there is k in the numerator, root k in the denominator. That is fine. But this will fail when something happens. What is the quantity here that you are kind of newly introduced?
Delta.
Yeah, this delta. So what is this delta? What can delta be positive? Is delta negative? So I'll write down what
Negative, sir.
delta is. Prof says that delta is the minimum of
Smallest positive number. No.
W star dot product with pi, right? Where pi is the minimum is over I, right? So all the data points. So remember that all points are now positive, right? So W star pi. So now can you tell me what delta can be? Can it be positive? Can it be negative?
Delta delta, if it's zero, it will be problematic, is my guess. Minimum
Correct.
is zero.
Yeah, so if delta is zero, so first of all, delta is non-negative, right? Because W star is, what is W star? W star is in some sense an optimal classifier, right? Or not optimal, but we know that it classifies all the points correctly. So W star dot pi is greater than or equal to zero for all I, right? So all data points are correctly classified because we have a linearly separable data, right? That's what we are trying to prove. So perceptron converges for linearly separable data. So delta is greater than or equal to zero, but delta can also be zero.
Yeah,
Okay.
if it's if one of the data points is on the decision boundary, then there's a problem.
Exactly, right? So if delta is zero, what happens to the growth of cos beta? So how does cos beta grow if delta is zero?
Inversely proportional, sir.
Yeah, inversely, right? In fact, it drops. So if the proof no longer works. Delta is zero, cos beta decreases as 1 by root k, or it as k increases, cos beta will tend to zero. So there's really no closure there. Okay, so though I'm sure all of you have done MLT, right? So, but for those who are taking this from on campus, all of you have done MLT. Do you see what is this point, the corresponding point in the MLT proof of perceptron convergence proof, right? In MLT.
That's on the decision boundary.
that it works only for linearly separable data.
Yeah, but this is also linearly separable, right? So there is something, that extra assumption that was made in MLT, which made the proof work there.
There's a margin.
Exactly,
Yeah,
right?
the
The
margin
margin.
was introduced.
So if delta is zero, the margin is zero because the point is on the boundary. So there's no margin. So this proof, you should probably add one extra point here that delta is greater than zero, and that will correspond to the margin proof that we did for MLT. Okay, so that point you have to note that delta is, this whole proof will work only if you have a linearly separable data set with some positive margin that amounts to saying delta is positive. Okay, so please make a note of that. Yeah, other than that, I didn't have anything else specifically to mention.
Actually, I raised this last time, Karthik sir, but
Okay.
then the conversation went into this, no, why are you initializing the weights to, then W should not be zero, and it sidetracked because MLT very clearly there's a case where it shows that in certain cases it will oscillate.
Right.
Whereas here it was assumed, it was like, so when you say this is a proof that it will always converge, then what I take W, initialize W, doesn't matter, right? It should converge irrespective. it was a little bit of an open-ended thing, but it was just week one, because this will all fade away. There's so much more which will come going forward.
Right. Yeah. Okay, so that's all I had. So shall we close?
Thank you, sir.
So one small thing,
Yeah.
the perceptron, like as the margin impacts our convergence, so picking up the initial weight also impacts our convergence.
Initial weight probably didn't have an effect there. It simplified our proof, if I remember. But does it? I don't think it affects the convergence guarantee, right?
No, not convergence guarantee. It won't affect.
Yeah.
It shouldn't affect.
Right.
Could it happen like since we have taken a particular initial weight, and because of that, somewhere our line fall on a point,
No, that
and we achieve that zero margin case.
I'm not sure.
Like in MLT also, like you provided us with the example, like, if I can remember, like one example where we had oscillation. So initially we were not on the point, we were not on the any data point, but since for a particular weight, when we updated our boundary, it fell on the data point, and when it fell on the data point, then since because of that zero margin thing, it got that oscillation thing.
Okay. Yeah, I'm not really sure about that part now. But yeah, as Vasu said, my guess also is that the initial value of the weight shouldn't matter for convergence, is what I also feel. But the margin certainly matters, right? That, as we have seen in this case also. And
Yes, the margins matter.
see, even here, right, the only fix you need to do is probably set lambda to be, sorry.
Yes, sir. So
So
if we will fix the margin, then initial will not impact, as we will not fall on the boundary, right? No data point will exactly fall on the boundary if we will
right.
set that margin thing.
Yeah. The
But in
only
that,
fix needed is the delta being positive. Yeah.
yes, sir. But in perceptron we don't have this thing, na? That's why we came up with those SVM things and all. Like we
Sorry.
don't have margin in initially in the basic perceptron algorithm, or we don't have that margin thing, na?
Right. So we don't particularly maximize the margin. So we don't, yeah, therefore we had to go for SVM. But implicitly the margin idea is there, right? So for it to converge, the margin has to be non-zero. But yeah, you are right in that we didn't actually go about focusing on maximization of the margin.
Margin. Like from there we picked up that margin plays a role in the conversion. That's why we
Right.
move towards that SVM.
Correct. Yeah, that's true. Okay, does anyone else have any other question? If not, please close for the day. Okay, so I'll just maybe stop recording.